Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of marginal, joint, and conditional probability. So first off, let's start with the definition of marginal probability, which is simply the probability of one single event without consideration of any other event, and it is also known as simple probability. So here is an example where you have a 2 by 2 table, really. So you have 2 rows and 2 columns, and this is how some sort of data has been organized into a table. Here we have 100 students in total, so we've got 100 students in total, and they were asked whether they are in favor of or against paying high registration fees for all new students. And you are asked to find the marginal probabilities, which in other words, the probability of one single event. So you can see from this table that there are 4 events of interest. For example, you may be interested to find the probability of that student being a male, or the probability of the student being female, the probability of the student in favor of the suggestion, or the probability that the student is against the suggestion. So we have 4 events, and you're going to have 4 marginal probabilities associated with all these events. Alright, so in order to find the probability that the student is male, okay, so the probability that the student is male, you need to know at the top part here, you need to find out the number of male students, and you can find that the number of male students is 15 plus 45, which is going to be 60. So that is the number of male students, and you need to know what's the total number of students. The total number of students is 100, so 60 over 100 is going to give you the probability of a student being male, and this is equal to 0.6. So that's the first marginal probability. Next, we move on to the next probability, which is probability of it being female. And again, the concept of probability is very simple. You need to know how many female there is, and you need to divide that number with the total number of students. So probability of that person being female is, find out what's the number of female. 4 plus 36 is 40. So we've got 40 female students over a total of 100 students. Therefore, the probability of the student being female is going to be 0.4. Okay, next we're going to move on to the next marginal probability, which is the probability of the student in favor of the suggestion given, in favor of paying high registration fees. So probability of in favor is going to be, again, how many of them are in favor. So in favor is this column, so you can see that the total of number of students that are in favor is going to be 19. So 19 over 100, so this is about 0.19, the probability of students in favor of paying high registration fees. And let's find the last marginal probability, which is the probability of student against the paying high registration fees. So we need to know at the top part again here, you need to know how many of them are against the statement. So we know that this is against, so the number is 45 plus 36, which is going to be 81. So here we've got 81 over 100, and the probability is just 0.81. So therefore, what we have done so far is we have listed all marginal probabilities. And what is marginal probability? It is a probability of a single event, just one event. For example, here the probability of it being male. so just one event, yeah. And this one, the probability of the student against paying high registration fees, so just again one single event. Okay, now can you guess what is joint probability? So joint probability means the probability of two or more events together. Okay, so in this case you can see that from the table here. So I'm just going to erase all ink on the slide, or maybe just this part. Okay, hang on. So in this case, joint probability is something that you have two or more events together. Okay, for example, probability of A and B together. So this is a joint probability. That means it happens together, joint. You can also have more than two events. For example, you can have probability of A joined with B, joined with C, and this is also known as the intersection process. Here we have A intersects with B, so you want to find the probability of A intersects with B. So joint probability is related to the intersection of A and B, or if you have more than two events, you have A intersects with B and C. So from this table, you can see clearly that there are few joint probabilities. For example, this one, okay, so this one, this is the intersection between male and in favor. So the probability of the student being male and the probability that student also in favor of the statement here is going to be 15 over 100. So this is an example of joint probability. You can see that this is the space where there is intersection between male event and in favor event. So this is an example of joint probability. Now what else? This is also another example of joint probability. If you consider this space here, which there is an intersection between female and against. So you are being female and you are against the statement or the suggestion. So this is another example. For example, we have probability of that person being female and intersect with that against the statement. So we need to know how many of them are female and against. So the number of them is 36. So 36 over the total number of students, which is 100. So this is an example of joint probability, which is 0.36. So I'm sure you have managed to understand the idea of marginal and joint probability. Yes. Okay. Perhaps another interesting problem is how can we visualize this example here using a Venn diagram? How does our Venn diagram look like in this scenario? So you can see that our sample space consists of 100 students, and they are divided with male and female, for example. So that could be our starting point when you want to sketch the Venn diagram. So it can look like this. So this is our sample space, and we know that it consists of 100 students. Furthermore, if you look at the number of male and female, you can see that male has about 60 students and female is 40 students. So that should give you a representation of a bigger size for male. Okay, so if I were to sketch the set for male and female, probably this is how it's going to look like. So I'm going to partition the sample space into two areas. So here is the area for male. So from this boundary here, defined as this boundary, so this is the set for male. Yes, and this is the set for female. So this thing. So maybe we are going to use different color just to illustrate the process. The blue line here, okay, so you can see that the blue line here is the sample space, and it consists of two events, male and female. They have no intersection between them. They are mutually exclusive. You will see the definition of mutually exclusive later on in the next video, but basically what we're saying that there is no like overlapping male or female, because really this there is nothing in between. We don't have gender that is in between male and female. So here we've got really clearly separated sets between male and female. So that's what's going on right now. Well, so maybe I'm just going to have this clearly defined. So this is male. Okay, this is for male. Okay, and then we have another one is for female on this other side. Okay, so this is for female, and there is no overlapping between them. Okay, so this is female. And we also notice that the number of male students about 60. So you can imagine if you have the number of elements there, you can imagine, so we are going to have about 60 different dots that represent all the different students. Yes, and on this side also there will be about 40 students on this side. Okay, so that's basically how it looks like. Yeah, and we also notice that out of 60 male students, 15 are in favor and 45 are against. So the number here is larger, and what we can do is we can perhaps visualize that idea by constructing another how do I say this, different set, where you have this one. Okay, let me just see. Okay, so for male, in favor is 15, against is 45. Oh, you can imagine having a set that looks like this. Male, so in favor is just very small, so maybe this one. Okay, so this is the intersection. You can see that this purple line here is the intersection of, this is the same area where it is also a male and in favor. Yes, so the total here is 15 actually, so 15. So it's going to be like total number of students here. You can imagine the number of red dots here is going to be 15, about 15. Okay, and I'm going to label this purple set here with IF, in favor. Okay, so in favor, and also male is denoted by this purple area, and you can see that this is also there is an intersection here because purple is inside the male set, so there is an intersection right there. Now on this one here, so this one here is a bigger area for against, and so this is for against, and you can expect that in this set there will be like about 45 red dots. Going to be a lot of red dots here. 45. Okay, about 45, so something like that. So that's how you can visualize the example given in the previous slide. And similarly, you may also want to visualize in favor for female. So again, I'm going to use this purple set here. So actually in favor could be like this. So this is in favor. In favor. Okay. There is in favor, which consists of some intersection for male and some intersection for female. So the whole thing here is in favor, set for in favor. Yeah. Okay, so the whole thing here is a set for in favor actually. So this whole thing is the set for in favor, this purple one. And like I said, you can expect to see the number for male here is going to be about 15, and the number for female students is going to be just 4, 15 and 4. So maybe 1, 2, Is this included? Okay, let's assume this is included, 3 and 4. So that's how the representation is roughly. Okay, and of course, if you talk about against, actually against is not just how do I say this? It is not bounded by this part here. Okay, actually, sorry. So against is going to be the whole thing. The set for against is the whole stuff here. The boundary is looking like this. So the whole thing here is against, and you can see that there are some part of against related to male, and there are some parts of elements here are related to female as well. And based on what numbers you have over here, for against you've got about 45 and this is about 36. So you can imagine the red dots here is going to be, the number of red dots is going to be about 45, and here is going to be about 36, something like that. Okay, so that's how you can visualize the problem given in the previous slide in terms of a Venn diagram. Okay, let's move on to the next part. We're going to talk about conditional probability here, and it is defined as probability that an event will occur given that another event has already occurred. So if you have A and B, and usually A comes first, the alphabet is A comes first, therefore we always use this notation. We say that what is the probability of B given A? So probability of B given A is denoted by this notation. So that is probability of B given A. A has already happened. So what is the probability of B given that you have seen A already happened in the past? Okay, so the formula is very simple. We have, if you have probability of B given A, at the top part here, it's going to be the probability of A and B intersects. Okay, or the joint probability of A and B, the probability of A and B happening together. So that is the top part. And since A has already happened, logically speaking, you will know what's the probability of A because A has already happened. So since you know the probability of A, then that information is going to be supplied here at the bottom part. Okay. Now, sometimes there is also a different notation used. For example, some people might be more comfortable to define the conditional probability as probability of A given B. So what does it mean in this case? It means that B happened first. Okay, so B has already happened and you want to know what is the probability of A. Okay, so probability of A given B, like I said earlier, it is very simple to come up with the formula of it. The formula is at the top part, we're going to consider them together. We're going to consider finding the joint probability. So probability of A given B is probability of them joining, of the joining events. So probability of A intersects with B. And again, we already know that B has already happened. So if it is happened already, you should be able to tell what's the probability of it. And so that information is going to be supplied right here at the bottom. So that's how the formula looks like. Of course, in different problems, you will have to use different alphabets because they represent different events. So if you are like comfortable with how the formula comes about, then it will be easy for you later on to translate all those events and using different alphabets in order to come out with the conditional probability. Okay, so as an example, compute the conditional probability in favor given male. So we know that this event has already happened. So we should be able to tell what's the probability of that person being a male. Okay, and therefore this can be written as probability in favor given that person is a male. So according to the idea which I have illustrated to you just now, at the top part here, we're going to consider the probability of them happening together. So we're going to consider what's the probability of in favor intersect with male. So that's the first part. And again, male has already happened. Okay, you know that this event has already happened. So you should be able to supply that information, and we're going to put it at the bottom. So we need to find what is the probability of it, of that person being a male. So if we go back to what we've done in the previous slide, so we go back to example 2.6, we want to find what's the probability of that person in favor, and also that person is a male. So we're just going to look at this table. Okay, so I'm just going to erase this part. It looks a bit messy here. Hang on. So we are going to find the probability of that person is a male and also in favor. Male and in favor. So we know that the number here is 15. So the probability of these two events happening together is going to be 15 over 100. So that's the first part. And since we already know that the event male has already happened, you should be able to find what's the probability of male. So probability of male is given right here, which is 0.6. So we're just going to put in those information and calculate the conditional probability. Okay. Now this one is going to be 0.15. Okay, 15 over 100, and at the bottom is going to be 0.6. So answer for this question, the conditional probability for in favor given male is going to be 0.25. Okay, I think that's all for now. Thank you very much for watching.